digitally and physically, my email is anthony@starfish.network, or come see me in person after I finish speaking. Thank you. With that, I'm going to introduce Matthew or Travis.
Oh, I got it.
Okay, cool.
Hey everyone, thanks so much for coming out. We like to do these once a month, various topics, and oh, if you go to YouTube, go to YouTube, go to /features, you should turn on the live stream. Oh, I did this instead. Actually, that should be fine. So just leave that one and close that. All right, sorry. Some last minute streaming issues, and in fact, if you're on the live stream, we'll probably be cutting off this whole beginning part while we're trying to get the audio working. But it should be all fine. We're also recording it, so we'll upload that later if there's any issue. So something we like to do here is at the very beginning, give people in the community a chance to kind of like talk up real quick, say, hey, I'm working on X, talk to me about Y. We call them lightning talks. This predates the Lightning Network, the name. I believe Fode wanted to say something. If there's anybody else who's interested, now would be a good time. Are you still interested? All right. And if you're interested, just come right over here. We'll just do like a couple of them.
All right. Good evening, everybody. My name is Fode, and I'm a local developer and a computer science student. And we are running a new meetup series starting this Saturday, April 13th, so about 2 weeks from now. And we want to basically share, or should I say, we want to not teach, but learn how to program Bitcoin from scratch, as a matter of fact. So we have like a reading group for Jimmy Song's Programming Bitcoin, and it's going to start on April 13th between 11 o'clock to about 1 o'clock in the afternoon. And it's led by myself and also Casey Bowman. And we want to just get some Bitcoin programming knowledge out there. So if you have some basics of mathematics, a little bit of basics of Python programming, we invite you to come through and maybe help us get off the ground and start learning how to program Bitcoin from scratch.
I am really excited about that event. That's really cool. We also, if you go on the Meetup page, there's another educational group we started recently, Ethereum Project Working Group. Just people who get together to work on Ethereum projects, but the idea that it's more than just Solidity. There's MetaMask and web app, and so it's kind of like covering all those questions. Next up, June.
Just real quick, my name is June. I'm one of the organizers of the Crypto World Expo. It's going to be a great event where people are going to demo their apps or their platforms. It's in San Francisco, April 13 and 14. Again, it's called Crypto World Expo. It's cwexpo.co. So I'm one of the organizers. Justin in the back is another organizer. So if you have any questions, just feel free to reach out and we'll be happy to answer any questions. But save that date. It's a weekend, Saturday, Sunday, April 13 and 14. Thanks, guys.
Oh, one more.
Hi everyone, my name is Justin from neuronpoint.com, and I have a startup that basically aggregated data from all the major exchanges. So if you're building a app that needs to have the infrastructure connect to about 40 plus major exchanges, real-time data, or aggregating your users' account balances and stuff to make any creative app, like something for competitor shapeshift, tax accounting stuff, you name it. We have the tools to help you, and right now it's free. So, and trading too. You know, you want to do market making to support your coin after ICO, whatever. So, neuronpoint.com. Please check us out or talk to me after this.
Okay. With that, I'm going to go ahead and hand it over to Matt. Matt's is a co-founder of BlockCypher. I'm really excited to have them out here because obviously Grin has a lot of really interesting implications for blockchain technology in the future, but there's not a whole lot of companies necessarily working on it yet, but BlockCypher is. They got the first US mining pool, very involved, so if you want to know anything about Grin, this is the guy to ask. So please, big round of applause.
Thank you. So my name is Mathieu Rioux. I'm the co-founder of BlockCypher. BlockCypher has been around since 2014, so we've been around for a while. We're a platform, so we help people like maybe you build applications, and we offer APIs so that we can consume them really easily. We support Bitcoin, Litecoin, Dogecoin, Dash, and Ethereum. But here I'm less here today to talk about that, but more about Grin mains. So we just released the mining pool, well, just a month, 2 months ago, which is a Grin mining pool. So we see it a bit as a continuation of building platforms. Mining pools are just platforms for miners. It's just the more specialized protocol, which was the same thing. It's the same way as API for the most part. And we started that, well, as I said, a couple of months ago. It's been working pretty well with the first sort of, Western mining pools. Kind of hard to compete with the like of BTC.com and F2 pool, but we're trying. And so today, so I'm going to talk about mostly Grin, but being a Grin mining pool, we're fairly interested in mining. And so if you have a graphic card, if you're a gamer, play in the evening or whatever, but the whole night your computer is not working, probably the whole morning. So you can mine, run the Grin software is actually, there's multiple types of software to mine. They're all fairly easy to use. And so you can try point it to Grin Mint and see how that works. It's kind of cool to get a few grains out of your already paid rig anyway. So yeah, that's actually my co-founder's boy. He built his own computer and he made a whole YouTube video, so I said I would show it. So that's the plan for today. The title is Grin 101, so I'm gonna sort of start sort of higher level. If you've never heard of Grin before, what it is, kind of what's the idea, what the project, sort of how it works, and then go a little more technical, and toward the end we'll just ramp back up. So yeah, the project. Sorry, I don't have the mirror, so I'll look back a little bit. So yeah, that's the sort of history. There's sort of the standard stuff that you've been used to. It's 100% open source, but compared to other projects, it's entirely community driven. There's no, single company that drives the whole thing. It's mostly funded by donations. It's written in Rust, so I don't know what the ratio of user developers versus not, but it's a little more safe than say C++, where you can always trip over yourself fairly frequently. So the project has been announced in 2016. It was the first Mimblewimble implementation, so I'll run into Mimblewimble and what it is and things like that after. That's kind of a short timeline of all the whole development. I don't know, maybe you've seen that before. So it was announced in 2016 as a Tor link, so anonymized link, dropped on an IRC channel by somebody whose pseudonym was Tom Jedusor, which I can tell you being French. He is the name of, so the alias for Voldemort in the French Harry Potter books. So in English, I think it's Tom Riddle. And Tom Rommel or Riddle, I think something like that, which stands for I am Voldemort when it's an anagram. So in French, of course, it has to stand for Je suis Voldemort and not I am Voldemort. And so the full name is, yes, exactly, Tom Jedusor, which is so maybe he's French, I don't know. Or she's French. And then, so it was, the paper describes a blockchain format, and that's about it. So it just describes, what a blockchain should look like, and good things about it, and how it can behave better, and I'll show you more about that. So from there, people picked up the paper and started refining it. Andrew Polstra was working on, I think, something similar, and so they were sort of, they've been increment on that idea. And then the first implementation was posted in October 2016 by another character called Ignatius Peverell. So if you're still on the Harry Potter sort of, Ignatius Peverell was the first person to get the cape that Harry Potter uses to hide all the time, the invisibility cloak. And then lots of work continued, and mainnet was released mid-January. Just a couple of months ago. So a common question might be why, wait another? Why not use, build on Bitcoin or use Ethereum or whatever it is that you like. Well, I mean, there's a lot of reasons that Bitcoin is hard to build on, and there are ideas in Mimblewimble actually where if you want to do it elegantly enough, you kind of have to, well, you can't really like, you know, build incrementally. And I mean, there's a lot of innovation in there that are kind of interesting. So that's the, I don't want to force you to read everything, but that's the README of Grin. It's some, well, a little hippie at the beginning, but it kind of reveals a bit that, you know, the overall approach is very collaborative and open, I guess. And then those are value propositions that have been cited pretty often. So with privacy, design is minimal, which, we at BlockCypher power other blockchains. So we run, you know, Bitcoin, Ethereum, Litecoin, all of that. And the complexity actually since we started in this space has only been going up. Projects get more and more complex, so you get, I don't know, you can start with Bitcoin, which is not, it's somewhat complex, but not super complex. Then you go Ethereum, which is a fair amount more complex. And then you go, say, Tezos, which is a lot more complex. And so it's kind of nice to see, you know, a project going a little bit back to the roots, maybe. And then it's community driven, so anybody can go and start contributing and say hi, what you guys are doing, and whatever. From a governance standpoint, oh, and by the way, I should say it right now. So I'm not part of any of the core contributors. We're going to employ a core contributor, Quentin Le Cellaire, who's also French, incidentally. And so we've been, you know, on the front of it for a while. So, but as a disclaimer, I'm not a core contributor, and all the slides are actually mostly stolen from other presentations. But you know, I know a good amount. So yeah, from a governance standpoint, it's fairly simple. They have meetings every week. One week is a more developer-focused meeting. Another week is more like a governance-focused meeting. Meetings are open, everybody can join. It's on Gitter. I don't know if you guys are familiar with Gitter, but it's one of the maybe 20 chat apps that you might have seen. It's more sort of GitHub focused. There's a console, which are more people who have been in the project for a while and so are more interested to take decisions and having the decision not being too stupid. So, you know, the governance itself is getting more and more refined. There's more people in the governance group and all of that stuff. Everything is in open again, so all the decisions, the finances, and everything. That's word that have been often used to describe Grin, which, you know, we've seen in the past few slides. And then, so an emission, which is a fairly frequent question. The Grin emission is 1 Grin every second. So the way it works out is there's a block every minute, and then there's 60 Grins per block, so that's 1 Grin per second. Yeah, it's kind of scary now. So it's mined by proof of work. There's a couple different proof of work algorithms. I'll go in there. And then, so everybody is like, what, you know, there's no constant amount of Grins, inflates forever. Well, not really, actually. Inflation goes to 0 because, you know, like right now, every new block is 60 Grins, and there's only 2 months of blocks passed. So, you know, 1 more block is actually a fair chunk of it. But 5 years from now, 1 more block will be basically nothing. Well, a small drop in the pool of all the Grin existing. And yeah, so after 8 years, there's only 33% more Grin that will have been issued than Bitcoin. And so in overall, you know, given the price fluctuation of, say, Bitcoin between, I mean, when BlockCypher started, it was $200, it went to 20,000. So it's overall, it's fairly negligible. Okay, so now I'm going to go, that was more Grin, the project itself. I'm going to go into Mimblewimble, the protocol. And that's, I'm going to start stuff, and that's going to go more technical, but hopefully not too much. There's only one mathy slide, I think. So the protocol is a new blockchain design I was saying earlier. It only describes what the blocks should look like and what the transaction should look like. It doesn't describe, like tons of other stuff that you have to do to the blockchain, like the proof of work and, the peer-to-peer protocol and all that stuff. There is no amount, no scripts. So, like all the cool scripting you can do with Bitcoin, although, people only use like 4 or 5 scripts anyway, but anyway, all the cool scripts you could do with Bitcoin or even with Ethereum, where you have all those like fancy programs that you can write and get hacked. There's none of that. There's no addresses, so that we'll see after. You can't, like all transactions are confidential by default, so there's no possibility of your transaction to be non-confidential. They're all like that by default, but you can, reveal a little more so that other people can sort of peek if you want to. And the ownership is proved by a single use key, so you can think about it like HD wallet. So if you used to HD wallet in Bitcoin, where every single time you make a transaction, it uses a new address. It's kind of the same idea. So if you can tell if your address is never reused, there's really no point in addresses. If no one can send twice to the same address and it's enforced by the protocol, then there's no real addresses. So yeah, there is no real addresses. So the way it works is transactions have to be interactive. So a lot of people, when you see interactive, you think, well, you have to be, always like face-to-face or online or interacting at the same time. It's not really the case. Interactive just means that you have to interact. The timeline or the medium is not dictated by the protocol at all. So you can do it interactive over email, and I can send you like my part of the transaction, so it's called a slate. I can send you my part of the transaction today, you can reply to me tomorrow, I can finalize next week, it's not a big deal. It could happen, over, so there's one way to do it, which is over like a chat app, where you can just exchange it right away. You can do it by email. You can do it like online through HTTPS as well. So the transaction is done right away. And I'm sure there will be other ways. It's still the early days, like people are developing all sort of ways to interact. So that's one transaction shape where the sender initiates. So if I want to send you some money, right, I initiate, you get my half of it, you complete it with your half, and I finalize the whole handshake. It can be done the other way as well, which is more like an invoice, where you tell me, hey, you owe me that much. I add my half, and then send it back and you finalize. So that's more like a merchant type interaction. So transaction, I don't know how familiar you are with like the Bitcoin transaction shapes. Like Ethereum works as accounts. Who here has heard of inputs and outputs? Before I go too much into, okay, half, okay. So Ethereum has accounts, which is like your bank account that you used to. Bitcoin has inputs and outputs, which are more like the bills in your pocket. So if I have a $5 bill in my pocket and I'm gonna buy an espresso at Blue Bottle close to here, espresso is $4 because it's San Francisco. I'm gonna give them a $4 bill, so now they have a $4 bill, and they're gonna give me back $1, so now I have $1 bill. So it's still the $5, which is in an output, and then I consume it by providing an input, which is like taking it out of my pocket, and then now they have my $5 output, and they gave me a $1 output, and I can spend later to buy not much with $1. And so this is that sort of inputs and outputs are what build transaction in the Bitcoin protocol. Again, Ethereum is different, it's entirely account-based. So Grin is like Bitcoin's inputs and outputs. So yeah, inputs reference all then spent outputs. So the $5 bill I have in my pocket, I haven't spent it yet. I just reference it by taking it out of my pocket. And then from there, there's two new outputs that are created, the $5 that go to the merchant and the $1 that goes back to me. And then, so in the Meetup protocol, there's what's called a kernel that's attached to the transaction, and that's something that you probably haven't heard of unless you're familiar with Grin or Meetup. And it basically, so all the amounts are obscured. So this is sort of the magic part. It uses a form of zero-knowledge proofs. And so given that all amounts are obscured, it's kind of hard to tell, that I haven't created money out of thin air, right? Like, I could just pretend that I've just sent 10 and actually I'm sending only 2. Or, and so the kernels are a way, because all the amounts are obscured, I can't tell. The kernels are a way to prove that actually the transaction balance, I haven't spent more than I have, or destroyed. And so the kernels are our way to put this little equation is that, what comes in the transaction and what goes out the transaction always balances. And the excess is the proof that's in the kernel that it all has to be equal to. So it might be, I don't know if I'm very clear, but the math might actually be. Okay, as I said, everything is obscured, so every single transaction looks the same. There may be a varying number of inputs or outputs, but the outputs all look the same. So if you look at the block explorer, Grin block explorer, it's not very interesting. All the outputs just look like a random piece of data, and all the inputs look like a random bit of data. So you can say that the block was produced, and you can have some sort of feeling about how many transactions are in that block, but that's about it. Okay, so that's the mathy slide. So the transaction in Meetup use what's called, construction called confidential transactions, which was designed by Greg Maxwell quite a while ago, actually. And this is, Meetup is a new way to leverage it, basically. So it uses what's called Peterson commitments, which are that sort of way to hide amounts. So you have an amount in there, right? Because if I send you money, I have to say I send you like, I don't know, 10 grams. But it's got to be hidden. So the way to hide it, so this uses the elliptic curve, but let's forget about it, elliptic curve for 1 minute. Say you have a way to represent my transaction on like an X and Y axis, right? Like your school X and Y axis. So say I'm gonna represent the amount on the X axis, and then I'll make up a number on the Y. And all I give you is a point on that like sort of X, Y axis thing. And if you don't know how the point projects trivially, like for some reason there's an infinite number of ways that the point can project back to the axis because I don't give you the orientation, for example, then you can't really find the amount back. So that's the same idea here. You get that other factor, which is the B times G here in the Peterson commitment, that kind of hides the amount and just make it look like some, trash data you can't really make any sense of. And again, the nice thing is because I projected my, point on a curve, like if I have some, all the math will still work, right? You can still do the same math of addition and subtraction on an XY curve. All the, like everything you do on the X will work among those points and everything you do on the Y. So all the math continue to work even if it's somewhat obscured. And then because you pick that random point on the Y axis, you have a way to prove that it's yours if you need to provide the Y again, right? So again, like if I spend like 3 grains, I'll put 3 on the X, and then I pick a random value on the Y. It doesn't really matter as long as we remember it well. If I'm forced to produce that Y value again, then it's me, and that I really own that output. So this is a shape of a couple of transactions with some color added just for illustration purpose. And so those are 2 regular transactions. You could see exactly the same thing on Bitcoin. And they can be joined together, so they can be merged, and it actually still works because the math still works. All I said previously, how the inputs minus the outputs, whatever, still works. So you can take the two transactions, pretend it was only one to start with, and that still works out. Still a valid transaction. And then here you can see there's like two things of the same colors, right? Because it was my example earlier of giving $5 to the merchant and they give me $1 back. If I spend my $1 right away on a pack of chewing gum, then the merchant maybe take the $1 back. And so there's this sort of $1 that went to me and back to the merchant. Is like, there's no point in $1 getting exchanged. The merchant could have kept it in the first place. So that's what this does, is like the $1 is on both sides, and so it can just be eliminated, and the math still works, right? Whether the $1 has moved or not, who cares? It's still just added in the same way. So then you end up with a much slimmer transaction. And similarly in the block, you have a bunch of input outputs that are across multiple transactions. They can be joined together to form a block. And then when the outputs are spent, so you can see there's all like similar colors, then they can be removed. And then the block ends up being a lot smaller for it, right? You've removed most of the information that was in there. So that's sort of the second innovation of Mimblewimble as a blockchain format. The first one is privacy. And everything is exchanged privately and sort of obscured by the old knowledge. And the second one is that sort of scaling, that you can remove most of the data all the time. And so you can tell, like, this is just one block. And so we've eliminated that block, but you can be like, well, it's kind of unlikely that, the merchant will give me my $1 back and I'll spend it right away. Well, it doesn't really matter, because if you add all the blocks together since the beginning of time, which is what you do when you download the blockchain, right? You get all the blockchain data since the beginning of time. Well, you get all the blocks, and you can do the same thing. You just pretend all the blocks were joined together, and then you can eliminate everything. So all you need to do when you do the initial download of the blockchain is you get the block headers, which are just the main descriptors of what the block is. You get what's called the UTXO set for unspent transactions outputs, which are all the money that has been spent yet, because everything that's been spent before, we were able to eliminate it. Every time something has been used, then it matches something that existed on the chain before, and so everything can be removed. And so all you have remaining is what's called the unspent transaction output, the one that the money we have in our pocket. And then the kernels, which, as I was saying earlier, just prove that there was no inflation, that nobody cheated in the system, nobody pretended creating transactions out of nowhere. So as a blockchain format, the advantages and disadvantages of Mimblewimble. So advantages is, so the privacy, right? No amounts, no addresses. I can't say it's you that transacted necessarily, because your transaction just looks like anybody else's, and I can't really tell what came in, what came out. I can say, okay, you got $1 back, hence if you spend $1, it's going to be the same dollar, and then it comes from you. There's no really amounts to do that. And then they improve scaling, because most of the chain data can be removed. So here's a little caveat. Most of the inputs and outputs can be removed. So the idea is the chain doesn't scale with the number of transactions. It scales more with the, so you can transact with yourself 10 times, right? Every input and output will be removed along the way, so all you're left with is always the output at the end. And so everything gets removed, so that's great. So it scales more with kind of the number of users and the number of transactions. The little caveat is the kernel. As I told you, you need to still be able to prove that no money was created, and that needs to stick around. And there are, people in the projects are also looking at ways to optimize that and even be able to mush all the kernels all together, so they don't need to be kept around necessarily in the future. So the disadvantages are the transaction need to be interactive, as I said earlier. So to build that sort of transaction with its kernel and it's fully blinded and things like that, we need to have a full back and forth. And that makes wallet a little more complicated and sometimes user interaction a little more complicated. There's only been 2 months since Grin was released. There's tons of wallets that are maturing right now. I mean, there's a few that have been released, more getting released. And so we'll see sort of, I don't know, maybe somebody will come up with some really easy and cool way to do that. There's still, on the privacy side, there's still some output linking, so you can trace, like, it's not, there's still some improvement that need to be made where, so if I give you my $5 because I owe you a beer, and then you get the $5 in your pocket, and then after we met, you go get another beer by yourself, well, I'll probably know because I'll see that you have spent the $5 I gave you. And I know it's $5 because I gave it to you, right? Nobody else does. But I do know that you might have spent that $5 right away after because I see it happen on the blockchain again. Because we made that transaction together, and so I know your outputs. So that's one thing that's still there. It's only between people transacting. And then another disadvantage is there's no scripting, so you can't do like crazy Ethereum DAO type stuff. But there are cleverness with cryptography that you can do, and that can still enable things like multi-signatures, atomic swap, and possibly Lightning Network. So there's no scripting, but there's still a lot that's possible with the cryptography itself. So I'll go a little bit more in the implementation. So that's sort of the implementation of Grin for Mimblewimble. Hence the, I don't even know how to pronounce it. Okay, so that's a set of technology that exists within Grin. So as I said earlier, Mimblewimble is just a blockchain format. It doesn't say very much about the detail of even what the signature scheme could be. There's multiple signature schemes that you can rely on. There's multiple way to prove different things. So Grin had to pick technologies for all of these, and they picked that set for various reasons. And so you may have heard of Schnorr signatures that are discussed for adoption into to Bitcoin. You may have heard of bulletproofs, which are, okay, so like just in 30 seconds, because that's getting a little more complicated, but if I send you some money, I can pretend, because all the amounts are obscured, I can put a negative amount in there. And then if all you look at is, it sums up, it will still sum up. From 5, I can create a 10 output and a -5 output, and it will still sum up 5 in, 5 out. So you need to attach a proof to every single output to show that the output is positive. And there's multiple of those proofs. The old way to do proofs was really large. And so there's been a new way to do proofs that are called bullet proofs that come out of Stanford, actually, that are much smaller. And so that's what's leveraged in Grin. Then there's scriptless scripts, so that's atomic swap and stuff like that, which, as I was saying earlier, is a way to sort of embed the scripting in the cryptography and the signatures and the public keys and stuff like that. And then Dandelion, which is an anonymizing protocol so that your IP doesn't show anytime you broadcast a transaction, basically. So now the proof of work. The Grin proof of work, well, the basic proof of work itself is called Cuckoo Cycle. It's based on graph theory. The idea is, it's kind of hard when you have a messy graph on the left side. Well, messy graph. When you have like 2 sets of points and a random sets of lines that connect them to find a graph inside that mess on the left-hand side. So the way it started is that we have 2 very large set of points, and then we're gonna create random edges between them, and then go ahead and find a graph. And it can't be any graph, it has to be a graph that's 42 long, that has 42 connections. And that turned out to be pretty hard. And so, I mean, here is a simple thing, right? Like, even looking at it, you probably have a hard time to find that the graph is on the left side, and I can assure you it was. I'll check. And so, if you have, so in one of the Grin proof of works, like one of these graphs here, it's 2 power 29 points. So that's a lot of points. And then you have half of that are connected. And so it's really hard to figure out where the graph is and what the length of the graph and all of that. So that's the basic mechanism of the proof of work itself, is finding the graph, and it has nothing to do with, you know, finding hash functions. So yeah, it has nothing to do with like running hash functions a billion times or things like that. It's just a complicated graph theory problem. For Grin, there's 2 variants of it. There's one that's more optimized to GPUs and one that's more adapted to ASICs. The idea is, you know, when you release a new coin, the ASICs are not going to appear like right away out of thin air. It kind of takes a while to develop them, and at the beginning, there's not necessarily a market for it, and so it allows a slow ramp up. So it starts with mostly GPU mining, and then little by little, the share of all the blocks that's dedicated to GPUs goes down, and then the share that's dedicated to ASICs goes up. So, and that takes about 2 years. So then, you know, at the beginning, it's mostly GPUs, and the ecosystem has about 2 years to, you know, get their shit together and produce some ASICs. Yeah, so yeah, after that, maybe. So the one that's GPU centric uses a lot of memory, and well, they both use a lot of memory, but the one that's GPU centric requires more, and so you can only sort of run that effectively on a GPU versus the one that ASIC centric can be run pretty effectively on smaller memory footprint. And the idea is in an ASIC you can't embed tons of memory; it's very expensive. That's when your CPU cache is very small, right? You don't have gigabytes of CPU cache. So current project focus, there was one security audit that was completed before the release for mostly the crypto parts. There's another audit that's going on that will be finished in about 6 weeks. So there's this sort of incremental auditing process that's going on. And then now, obviously, a lot of people want to develop stuff like wallets and exchanges and everything, so that needs a lot of helping out for all the people involved in the project. And then Windows support, which I think is going to happen in their next major release. Okay, future RS. So a lot of it is sort of research. So, you know, I'm mentioning it just because it's fun and interesting if you're into that sort of thing, but it's still very early stage, it's not there yet, and who knows, maybe it's not gonna land really, but you know. It's at least been mentioned repeatedly, so hopefully it will happen. So Fly Client is a way to have light client. So what I was telling you about, you download the blockchain, you know, it's a whole bunch of data. So first thing, you have to download all the headers, and the whole headers have the proof of work. So you really need to use the headers, because otherwise I could totally cheat on you and tell you this is my chain, and you have to believe me, even though I mined it with my laptop, right? So you really have to check the proof of work to say, okay, this has been validated by millions and millions and millions of petaflops or whatever it is. So Fly Client is a way to say, well, you actually don't need all the headers. You can just, you know, select some randomly and check out, that's fine. And it turns out you actually don't need that many. And so you can download the blockchain much faster that way. It's especially useful for light client, like your phone, right? Then there's probably going to be some flavor of Lightning, because it's possible with the you know, fancy cryptographic tricks that you can do with signatures and public keys. Confidential assets, so Mimble uses confidential transaction. That's what hides all the amounts, and you know, you have no address you use and stuff like that. There's a way to do assets with that. Still keeping, you know, but you can do assets and random assets. So you could imagine, you know, having Ethereum on the Grin blockchain or things like that, or you can create your own asset if you want to. Universal accumulators are kind of a fancy trick, but I'm not going to get into that. And then BLS signatures are an alternate way to create signatures, also coming from Stanford. Actually, the B stands for Dan Bonnet, who's the cryptographic chair at Stanford. And so would allow to compact all the kernels. So remember I told you earlier there's inputs, outputs, kernel, and the kernel will have to remain to show that there's no inflation, that it didn't create money out in air. So BLS signatures would allow to still compress all those kernels into a single one and still be able to prove the whole thing, which is kind of cool. So where everything is at now, from like a tooling and everything, it's still the early days. It's only 2 months. 2 months into Ethereum, it was pretty hard, I can tell you. So of course, mining pools. There's several mining pools, but there's only one that's worth checking. And F2 pool is tiny, really tiny. Okay, so there's a ton of stuff that have been happening in the last 2 months. It's actually been somewhat busy. So there's multiple mining software provider, like stuff you will install on your computer and will start mining. So again, if you're a gamer or you have, graphic card lying around on your desk that you haven't used for a little bit or whatever, there's multiple mining software. Now there's actually optimization that allow you to use even graphic cards with lower memory. It's of course not as efficient, but you can still use them and have fun with them. Then there's at least 3 ASICs that we know of that have been announced. So yeah, the third one is just like a post on Twitter. So far we don't really know that much about it, but there's at least a obelisk in InnoSilicon. There's an alternative C++ implementation. There's multiple white projects. Here are some, some are more command lines, some are more mobile, some are desktops, some are like Windows only, things like that. And then there's multiple exchanges. The largest one is probably Poloniex. Chainriff, is also another exchange, and they also released their wallet. So tons of stuff happening. The link at the bottom is all the community projects. There's like a page where everybody can list their things. So if you do one, you can also list one there. So we donated already a little over $25,000, and then 0.5% of all the reward that comes from Grin Mint is donated to the project, so that the developers can pay for their bills and stuff like that. Again, it's not there hasn't been any ICO, there hasn't been any pre-mine or anything like that. Actually, the first block we were talking with you earlier, that the first block might have been one of the most expensive ones because it took multiple hours of mining to produce it, and then there were more, so obviously no pre-mine. So the project kind of needs still a lot of money to continue, and so far they've been good at saying what they're spending, where they're spending it, things like that. And so if you have any way to contribute back, I think that'd be very welcome. There's a funding page. There's a link. And then, yeah, so the project is open source, so if you're a developer, there's actually plenty of roles that they are looking for, but it's actually open source, there's no trademark for the Grin name. As far as, I've seen, everybody can come up and start proposing some PRs and stuff like that. That's how so Quentin, the person we hired, starting just that way. He was interested in some part of it, started looking at the code, proposed some code, people reviewed it, and then after a while it was accepted, worked on something else, and so on and so forth. So it seems, really open. There's again a chat app where everybody seems to hang out, so you can check that out. And yeah, people are actually nice, which, it's a little refreshing. Maybe it's because it's still small and things will go like sideways like for every other project, but so far it's good as long as you don't hang out on Reddit. And then that's about it. So if you have questions, I'll be around.
Yeah, we can do a quick Q&A. Is that
Oh yeah. That's true.
but hey, thanks so much for the presentation.
Thank you.
We're at So if you want a question, you raise your hand. While I get the mic, maybe you could start off. The Bitcoin blockchain's like 250 gigs right now. What is your guess in a couple of years as to how, with pruning and the research, like a reasonable guess exactly how big Grin's going to be?
It's in a couple of years, I would guess maybe a few gigs. I haven't run the math, so that's kind of a wild-ass guess. But that would be probably the ballpark. As I mentioned, there's additional compression techniques.
I didn't take the number, sorry.
Oh, around a couple of gigs, probably. Yeah. That would be my guess, but as I said, I was just guessing. You can sort of run the math based on block sizes and things like that. It's also depend on use a lot, right? So if there's, only the people in this room that have Grins, then it's going to be a lot smaller than if it's half of Earth.
So Dimitri De Figueiredo here. I'm curious about the multi-sig part of Grin, right? So today, if you run any sort of like custody solution that you want to be sure that people don't steal money, you need to have multi-sig because of Quadriga, Canadian problems, for example. You just need that kind of resiliency. What's the story today for doing multi-sig in Grin? Is there a solution? What's the story today?
Yeah, so there is a solution. Actually, I think it's supported by one of the wallets I mentioned. And the crypto totally allows it. So the transaction still has to be interactive. So, if I want to send money to like all of you, all of the Grin Mint proceeds will go to all of you. Then we need to interact. So I need to interact with every one of you. Now, it doesn't need to be in any special order, but there still need to be this interaction. It's good that you don't need to interact with each other, right? But so if I interact with each one of you, then I can build a transaction that's multi-sig over all of your outputs, and you all need to agree. Yeah. So the question is, if I direct it to a multi-sig wallet, do all the parties that hold signatures have to interact? Yes, that's correct. So okay, so the term multi-sig wallet is a little weird to start with because in general it's not a wallet, but it's multiple people that have keys. But and then they all have their own view of the wallet. But yeah, so basically you have to interact with each view of the wallet of the multi-sig, and then you can produce a multi-sig transaction. It's not necessarily more complicated than a single person. It's totally parallelizable. But you still have the interaction. But the crypto entirely allows it. You can you build all those outputs. You do some like fancy math with the signatures, and it produces a standard output that's multi-sig. The nice thing though, it looks like every single other output. You can't tell that the output is multi-sig. Like in other cryptocurrencies, usually like in Ethereum, you'll be able to tell it's a multi-sig contract. In Bitcoin and all its clones, the first character of your address will be different. In Grin, they just look the same. You can't tell any difference.
Awesome. So since Grin has an uncapped emissions rate, the significant portion, the block rewards represent a significant portion of the total supply. And since the mining pools will have to sell Grin to reward their miners with Bitcoin, how do you think that will probably impact the price as an early stage project?
Frankly, probably the same as every other cryptocurrency. Bitcoin, the first 4 years, you were talking about early stage, right? Bitcoin, the first 4 years was, as far as everyone was concerned, flat supply. Ethereum, they cut down their reward, I think, at least after a couple of years of starting up. Pretty much every single cryptocurrency introduced days for, Monero had a very sort of, kind of get rich quick kind of get rich quick kind of curve. But most of the cryptocurrency, like Zcash, you know, it's 4 years, also flat. So the first 4 years is the same. It's not going to change anything. After 8 years, there will be a few more coins, but I was saying earlier on the compared to price movement, it's fairly negligible. So from a pool standpoint, we don't see things being any very different compared to any other coin, and I don't think the supply has any and like a lot of impact on it. The green supply, at least.
Hi. Thank you for speaking today. It's a quick question. What do you think? Do you see any issues or barriers that may impede the success of Grin? And similarly, what do you think is needed for Grin to be successful?
I mean, it's a young project, so there's always a lot of barriers. So, I mean, one is, so as I said, transactions need to be interactive. So there's a couple of things that can be done here. First one is UX, you know. You can, I think you can work UX pretty well to make that not to remove friction. There's some ways, actually, Wet 713 is one of them that so it still needs to be interactive, but you don't need to be online, and they have some sort of little store where you can store your intermediary transaction until, you know, I come online and I pick it up and finalize it and stuff like that. So it works a lot like an email exchange, you know, you send me an email, you know, I'm sleeping, I'm not gonna get it in the morning, I look at it, oh, I reply, and then you look at it when you're ready. So, so there's a lot of UX that's possible there. You know, everybody's on chat app nowadays, so they're like, hey, are you ready to receive my transaction? Yeah, sure. And you tend to do that also with other cryptocurrency. Again, if you use HD anyway, you're gonna want to issue a new address for every person that, Bitcoin HD wallet, you're gonna want to issue a new address at every time. So there's some UX work for sure. There's some research work to sort of like, you know, iron out maybe some of the problem. Maybe that interactive problem can be solved also at the cryptography level. I don't know. And then there's funding. You know, there's not a lot of money. You can tell, like, we contribute to every time a developer asks for money and stuff like that. But some of those campaigns have lasted for a while before they were able to like get some money and not go broke and have to work on something else. So that would probably be the two biggest issues right now. So to help them, well, and the third one is, you know, it's an open source project, so money and time is the same thing. And so the third one is contribute. So yeah, that's basically your three main levers. You can, and you know, working on UX is part of contributing. So really it's only two, it's contributing to the project where it's needed, and money so that somebody else can contribute for you.
Hi, thank you. Could you say something about Beam?
Sure. So, I described Mimblewimble, which is a blockchain protocol, which came out, I don't know what I said, but 2016, something like that. And so Grin took, I guess, 2 years and a half, well, a little over 2 years to release, and then in parallel there's another implementation that started called Beam. That started last year, I think, and then they released just a week or two before Grin. So the main difference is they're kind of often mentioned one with the other because they both implement the Mimblewimble protocol. But that's basically, well, like where it stops. Beam is a lot more like Zcash in terms of the way it's structured. It's controlled by a single company. They have a founder's reward as well. So, you know, in Zcash and Beam, actually, I don't know exactly what the share in Beam, but I'm assuming it's the same as Zcash, but I'm not 100% sure. For every block, 20% goes to the founders, like the company that funded the project. And after that, it's a foundation that's supposed to take over, but that's kind of, you know, every block being mined, there's a chunk that's going to the company. For the most part, it's only controlled by that company. So, you know, if you come and say, well, I really like Beam, but I wish it supported, you know, whatever, they're probably not going to tell you, oh yeah, let's do it. And so it's a different approach. Grin is much more, you know, like Monero, like well, Bitcoin was like, Litecoin, like, it's been created out of sort of thin air from people who are anonymous as well. So I think the Grin developers, there's 7 people that are the Grin core team. And 2 of these are, entirely anonymous, including the project founder, who might pull a Satoshi, I don't know. And so, there's kind of a very different approach. The base of the blockchain format is the same, then after that, the standard is different. The proof of work is different. Every detail I talked about, except for Mimblewimble, is different. And again, the sort of ethos and approach is somewhat different.
Hey, thanks for the talk. It was really good, thank you. So there's an article that came out yesterday called Grin Cryptocurrency to Vote Unchanged for the Hard Fork. So I guess every 6 months there's a upgrade, right? But in this particular upgrade that's coming up in July, there's going to be like a vote. I was wondering if there's going to affect the price or affect if there's going to be like a split, because whenever I hear hard fork, I hear something, it might be a split. So, but I don't think that's what they mean. I think this is more of an upgrade. So I just wanted to get your thoughts on this. Is this something to be concerned about with this particular upgrade?
So, in my opinion, and after that, I don't know what affects price. So maybe the price will crash after, or maybe it'll triple after. I have no clue. But that news doesn't change really anything much. So the hard fork schedule was, as far as I know, was already planned, sometime last year. And the idea behind it was just to say, well, we might screw up, and also there's, we think we gonna have to, have more like new stuff that's gonna come up and might not be backward compatible. So there's gonna be this hard fork schedule, and it's every 6 months for the first 2 years. And so as far as I know, I think this was agreed upon last year, and so that's not changing. Like everybody knew about it last year, everybody knew about it on the 1st of January, everybody knew about it on the 15th of January, everybody knew about it last month. So that's not changing. From my understanding, what's, because I read that article too, what's changing is that, and that's getting a little subtle. But there's 2 proof of works, right, I mentioned earlier, one for GPUs, one for ASICs. And then for the one that's for ASICs, so the one for GPUs, is gonna like sort of go down over 2 years, and then it's gonna mostly transition to ASICs. The one that's for ASICs, there's some kind of upgrade schedule so that new ASICs have to come up regularly. And so that's what's at discussion, is whether that schedule keeps getting enforced and ASICs get sort of obsoleted regularly or not. Or maybe only once, and then after that it just stays that way. And so practically, I don't think this, especially it's like far away, right? I think the first sort of planned obsolescence I'm talking about, I think the first one is at least in a year. And then the next one is, even further. So, well, A, there's time, and B, it's just discussion on what's going to happen in 2 years. So, there's plenty of time for every market to sort of factor that in. But I think it's well, for miners, it can be, especially for ASIC miner, the people who are making the ASICs, like if you're Obelisk and Intel Silicon, it's material. Or like Bitmain if they ever decide to do an ASIC or whatever. But for individual miners, well, large-scale miners, it might be material because they might need to renew all their hardware regularly. But you as, me as a user or whatever, even in Green I don't really care. And so, yeah, I don't think it's going to have a lot of impact.
Hi, thanks for the talk. Is there currently a difficulty adjustment to the cuckoo cycle algorithm to make it more or less difficult depending on how quickly blocks are happening, where you add points or add edges required?
Yeah, so, okay. So there is a difficulty in every single other coin you're used to. The idea is that, so you have it's the same as the other. So hash cache, right? You hash repeatedly until you find enough zeros at the beginning of your block, basically. So cuckoo cycle is the base, and then you're forced to do multiple cuckoo cycle rounds repeatedly to match a given difficulty. So it's kind of a combination. And so there is a difficulty that changes with every block that's calculated over, whether blocks have been happening too fast or too slowly. And actually even a factor that goes into it too, because, as I said, there's two proof of works. So say all of a sudden there's like tons of ASICs that come on the market. Well, you don't want to have the ratio between the GPUs and the ASICs vary too much because it's pre-agreed, right? Like, so if it's supposed to be 50-50, well, it's gotta stay 50-50 even if the ASICs double. So there's some kind of ratio in between too that adjusts with every block as well.
Is there any particular reason cuckoo cycle over hashing?
That I wouldn't necessarily know much because I wasn't there at the beginning. You'd have to probably ask the early developers. My guess is that when you release a new coin, you can't necessarily. So it's dangerous to say I'm going to start a new coin is going to use SHA-256 caching, because then you have all those SHA-256 hasher out there, and you can get attacked every day. And if people are bored mining on Bitcoin Cash, then they'll attack you, or Bitcoin Gold, or whatever it is. So it's kind of dangerous to use an algorithm for which there's already a large amount of hash power. So I guess, Zcash came up with Equihash, which was also brand new. So I guess same idea here. Yeah, so it's mostly security. It has some impact on like the mining landscape. Like Cuckoo is somewhat memory hard, so it requires a fair amount of memory, which lends itself more to a blend GPU ASICs, but then it can adapt it. It's fairly adaptable. So I guess that's a good part about it too.
So one more question. Yeah, last one.
Hi, thank you for the talk. I'm curious about one of the more unique things about this, which is the wallet. Could you kind of expound a little bit about how the information gets stored on a client? Because there are private keys involved, but it's not like you're storing one private key per wallet for an account. Yeah, could you just like talk a little bit about how that works?
Okay, so it is actually still just a private key. The problem is, so you have your private key, and we'll take, I don't know, Litecoin. You have your Litecoin private key, and you want to say, what's my balance, right? So from that private key, you can directly calculate your address, and then you get services like ours that index the whole blockchain for all the addresses that are in there, and so you can directly look it up, and we'll tell you here is the balance, and here are the list of transactions, and that's why you can look up your transaction really easily. And nowadays, it's commoditized that you'll have services that scan the blockchain and look for all addresses and whatever. The problem is people like us, we can't scan the Grin blockchain, right? It all looks like random data to us. We have no idea whether it's your output or not. And so the only way to know whether it's your output or not is to have your private key, which obviously you wouldn't give me, maybe. And so you gotta resort to other mechanisms. So you can still have your wallet scan the whole blockchain for you and try to spot which outputs belong to you, and that will work. And so even if you lost your whole wallet, but you saved your private key as a good person and you buried it on your backyard, then you can dig a hole again, get your wallet out, and recreate it. The thing is, it's kind of an expensive process, as I was saying, because you need to rescan the whole blockchain. It's not super expensive. I mean, the chain right now is not super big, but I've done it multiple times. It's like, a minute, 2 minutes. Actually less than that, I think. When the blockchain is like, millions, billions of blocks, it's probably going to be longer, but, if you lost everything, then you can wait a little bit for it to restore. And because it's an expensive process, then the way it stores data about your transactions so that you can look it up quickly. So when you start your wallet, you know, it has a little database and we'll say, okay, we already know this is his output, there's no point in looking again. And here were the amounts transacted and whatever. And so it's become the wallet's responsibility to track your transaction, and not everybody can track your transactions for you. So that's kind of the, you know, the trade-offs. But then once you have that mechanic in place, then it's somewhat easy. It's the same, you know, you have the database with amounts and stuff, and it's confirmed by the blockchain, and you can check that it's confirmed and refresh it when your output happens and stuff like that.
All right, thank you so much.
Thank you.
I completely forgot I had a Grin shirt on under my sweater. So there's still pizza, there's still drinks in the back. You hang out, talk, you know, discuss the ideas. If you get a chance to stack your chair, that'd be really helpful. The closer you stack them to those doors over there, just against the wall,